Hey, so it's Rich from Planet PE and we are live again on our revision session. So we've got 2 Sundays left before our first exam for our paper 1. So anyone who's just joined in, put in the chat, get your requests in about the topics that you want us to go through. And I say us, it is just me, in our GCSE PE revision session this evening. So what we are planning to do is try and run through, looked at in some of the other videos, trying to give ourselves an opportunity to try and have a look at the things that may be a bit of an issue with the internet, which is a bit of a pain in the backside. What's happened there? Right, we're now back on. Good old technology, you can't beat it, can you? So hopefully we're back in the room, because for a second there I lost all my connections, which has never happened actually on these live ones. So let's switch to, here we go, hopefully we're back live. So if you're watching this in delay, I'm sorry. What's going on with the internet today? Good old Virgin Media, you can't beat it. Right, if you are in the chat in a sec, hopefully you can say hi, and hopefully people haven't all lost what's going on, because it was a little bit annoying there that we lost the internet. So what we are going to have a look through today is trying to make sure that you all understand what is potentially going to be in the papers, those things that are going to be the focus topics, the things that maybe aren't going to be in the topics quite in the same way, but still you might be able to use your information and use your answers. So as I say, if you are already in the chat, put any requests in that you need to know. There's super chat available, there's all the different aspects that you can do if you want to. So let's have a look at who we've got in so far. So we've got a few people already joining us, which is amazing. So this is where we are trying to go. So let's go from this. So as we know, paper 1, guys, paper 1 is about applied anatomy and physiology. It's about movement analysis and about physical training. Now, every single question as well could potentially have some sort of data question. So these are the things that we know are going to be in the exam, and that's always the case. So what we want to see today is any topics that you guys want to go through, anything that you're not sure on, and that's kind of where we are with these sessions. So they're live, they should be interactive as possible. You guys in the chat can try and put as many things in you want in the chat to try and give us as much interactivity as possible, so that you guys can try and hopefully see the topics that you're not so good at, and I can try and help you. So let's carry on with this then. So we know that it's going to be on that. So we know that there's going to be elements about the skeleton, the things about locations, the structure, the functions, the types of joints, the structure of a synovial joint. These are all the topics that could be answered, whether it's a big bit or a small bit. Muscles, we need to know the location of the muscles. We need to know about which muscles are responsible for each movement. We're definitely going to go through that. Cardiorespiratory system, so the pathway of air, gaseous exchange, blood vessels. Blood vessels is quite a big topic in this year's one for the AQA guys. Structure of the heart, cardiac cycle, mechanics of breathing, and spirometry traces, which is again a real focus topic for us. Aerobic and anaerobic, the effects of exercise, movement analysis, physical training, and then we'll do all these different bits in here. So I'm just going to go back to that holding page so we can try and see what's going on there. So lots of people already in the chat. So is there anybody in the chat who needs any particular topics? We can start on those, or we can just go through any particular order. So all these revision sessions, guys, trying to be as interactive as possible, trying to get you guys at home to try and help you out, to try and give you as much as possible. And that's kind of the aim. So I'm going to start looking at these different bits. So where we are understanding basically about joints, about the body, about the movements that are going to happen, so in how that occurs, because where we are in GCSE PE is that we want to all understand these different aspects, okay? Because if we don't, then some of the other bits are going to be a bit more difficult to try and develop and to try and get. So where 2 bones meet is basically a joint. So when we define it, it's quite simply that we've got a bone meeting and a bone meeting, and that's going to form some articulation or movement. Now, when we go through with the muscular system, when we go through about how that happens, it's going to be really, really key. Now, this area isn't a particularly large focus topic, but it still may be in your exam. So we know that we've got these different joints, and within the body we have ball and socket joints and we have hinge joints, and the movements that are possible at different joints is purely because of the structure of that particular joint. So if we take a ball and socket, we literally have a ball, we have a socket, and it's going to move around in there. Now, does anybody in the chat know any of the movements which are possible at a ball and socket joint? So it's a joint which we're going to find in the shoulder, it's a joint we're going to find in the hip. So are there any particular movements that are possible at a ball and socket that maybe aren't possible at a hinge joint, or vice versa? So a hinge joint, just like a door, we're thinking about how it's going to meet, and it can only open and can only close. And a hinge joint can only do flexion and extension. So there's different things that can happen in different movements, or because of different joints, because of how they're structured. So when we look at the synovial joint of the hip joint or the shoulder joint, we're looking at being a ball and socket. And basically a ball and socket can do flexion, can do extension, can do abduction, can do adduction, can do rotation and circumduction. So basically every movement which is possible. Now, some of you out there might be looking at this going, what is circumduction? Well, circumduction is a movement that goes through all of the different range of movement. So we can go through flexion, extension, we can then go through abduction and adduction. So it basically goes through the whole thing. So if you're thinking about, let's say, bowling and cricket, almost that windmill type action, that is what we call circumduction. So that's something that cannot happen in a hinge joint. So a hinge joint can't do circumduction, it can't do rotation. A hinge joint can only do flexion and extension. Thank you very much, Ben, very much appreciated. So where we are trying to develop in here is there, if any topics that you guys really want to look at, that is the point to do. This is live, it's also there for the people that aren't watching it live to try and go through that way. So what you guys all need to understand is about all of the different movements which are possible. So we know we can have all these different things. Now, we also need to know things about the functions of the skeleton. So the fact that all flat bones are there to provide vital protection for the vital organs. So the fact that I'm going to head a football, it means that my cranium is going to protect my brain from injury when heading a football. We've got structural shape and attachment. So the fact that my muscles are on my bones, which then pull the bone, and then that is what's providing that attachment point for movement to occur. We've got blood cell production, so it's your long bones that actually create your red blood cells, okay? So again, something that is really, really important. We've also got the stores of minerals, so we've got things like phosphorus, we've got calcium, which is going to be stored in the bones, okay? So therefore, that's going to help us with our health and keep them nice and strong, so therefore, when we move, we're not going to be causing any injuries. So there's lots and lots of things. So when we're looking at the structure and functions of the musculoskeletal system, those things that are on the screen at the moment are the key points. Now, when we look at the muscular system, we need to understand about basically how the muscles are going to create movement by pulling on the bones. So a real popular question that comes up every single year is that we are going to be in a situation where you will be asked about how the the musculoskeletal system is used to create movement. So that's a real popular question. It comes up every single year. So where we need to really understand is the fact that muscles are connected to bones via tendons. So we have our muscle, we have a tendon and the bone. So the tendon is the thing that connects those two together. The only thing that can happen to the bone is that it's pulled by the muscle. And with that, we talk about how they work in antagonistic pairs. So in antagonistic pairs, basically, it's one of the muscles works as it pulls, the other one relaxes, okay? They can't both pull at the same time, essentially, for movement to take place. So these are the sort of things that you guys need to understand. Now, within that, the muscle contraction, it comes in two different ways. We have what we call isometric contraction and isotonic contraction. An isotonic contraction is basically where we've got that lengthening and shortening as we're talking about. An isometric contraction is there is no change in the length of the muscle, so therefore there's no movement that takes place. So if you're holding a position, let's say a handstand, let's say on the rings in gymnastics, the pause part of a scrum, that would be what we call isometric contractions. Okay, so they're the sort of things. So I'm just going to go into the chat and see what people are talking about, see what sort of things people want to look at, because again, it's as interactive as possible today for the hour that we've got together. So Arthur, what do you think of the OCR exam board for PE? So it's different. I teach AQA. OCR has a few differences. So for instance, in OCR, they need to understand about the about valves in the heart, about the bicuspid valve, the tricuspid valve. We don't need to know that at AQA, so it's a little bit different that way. Ayan, sorry, how do you link the functions of the skeleton to a sporting example? Right, I'm going to go back to that slide, make myself a bit bigger so I'll get rid of everything else. Okay, so this is, again, quite a popular sort of question that you guys might need to do. So let me just try and shift me around a little bit. Here we go. Right, let's just transition that into there. Okay, so what we are saying then is that we've got these different functions of the skeleton. So we've got protection. So you would use that sporting example to say that, for instance, the rib cage protects the lungs during a rugby tackle. And you would need to talk about the lungs being protected from damage because of the bones there are there to protect. If we're talking about things like structural shape and muscle attachment, the fact that we are the shape we are, the fact that we've got muscles that are being attached to the skeleton means that their movements can occur. Same thing when we talk about the formation of joints. Without the two bones meeting, we wouldn't be able to move. So you're bringing in really simple examples for that. Obviously, red blood cells carry oxygen. So therefore, that would be the thing to discuss for that one. And then store of minerals. So if we didn't store the minerals, the bone strength would be weaker. So for instance, if I was to absorb the tackle of from a football match, then more potential where I might be injured. So that's kind of where we are on that one. Right, next one. So cardiovascular system, we can look at that in a second, absolutely. And components of fitness and principles of training. Yep, so we can look at those in a sec. No dramas. So let's start then by let's have a look at the cardiovascular system. So a couple of things to do in here. Right, so the cardiovascular system is really called the cardiorespiratory system because the cardiovascular system and the respiratory system are linked, okay, and they're things that we absolutely need to kind of understand. Now in the exam, we need to develop more understanding of things that happen and why they happen and when they happen. So in your GCSE exam, you're going to need to understand lots and lots of things around gaseous exchange, about how it actually happens. We know that you're going to be asked about blood vessels, and we're going to be needing to understand maybe the differences between them, about their biology, essentially, about how they're actually structured. So when we're going through this, again, in the chat, if there's anything that you're not sure about, just talk to us. So let's take the respiratory system first, okay? So the respiratory system basically are our lungs. It's how air is getting from the environment into the body. So it basically goes in through the nasal passage, okay? It can go through the nose, it can go in through the mouth. It goes through the trachea, through the bronchi, the bronchioles, and then it goes into the alveoli. So the alveoli is like the last stop. Now, there's been questions before about just simply labeling and just put a number about where they are. The best way that I always think is literally flip it upside down. So imagine you're thinking about a tree in reverse. So you've got this idea that it goes into the trachea. Well, that's the trunk of the tree. You then got the branches, which is the bronchi. You've got the twigs, which are the bronchioles, and then the leaves are the alveoli. Now, if you think of it that way, it's very similar about how the air gets in. So we know that the leaves do all the work on a tree. The alveoli basically is doing all the work for us in gaseous exchange, because we need to find a way of getting the air from the atmosphere into our bloodstream, and that's where the respiratory system and the cardiovascular system meet to become the cardiorespiratory system. So if you take a look at this bit here, gaseous exchange, so the features that are helping gaseous exchange to take place. So alveoli are really, really thin. They're one cell thick. They are also permeable. So what that means is that air can get from the environment, it can get through our lungs, it can then get through the alveoli and then into the bloodstream. Okay, so that's really, really key. So we are talking about how air is going to be from our environment and eventually get into our muscles or the working tissues that it needs to get by. So when you're working through it, like I say, I would start by thinking about this upside down tree. That would be the kind of the way for me to think about that. So I've got trachea, bronchi, bronchioles, alveoli. Now, we've then got this idea that we're going to be getting the air from our respiratory system into our cardiovascular system. So we have capillaries. Now, capillaries are the tiniest blood vessels that we have. They're really, really, really small. And what that means is that the air is going to pass through the alveoli, through the capillary, so therefore it's then in our bloodstream, and then it's going to get picked up by oxygen, and if oxygen then binds to the red blood cells on the hemoglobin, I should say, we then got something called oxyhemoglobin, and that's something that you might see in your exam. So it's gone from the capillaries into the bloodstream. Now, we've then got the differences between the different blood vessels. So the blood vessels are basically the things that are going to be carrying the blood. So it's just like a ship as a vessel. So if we look at the differences here then, so we've got arteries, which are the largest of our blood vessels. We've then got veins and we've got capillaries. And there are some differences around them about what makes them what they are. So an artery has a really, really thick muscular wall, and it's quite stretchy, it's quite elastic. And the reason for that is that the blood that's getting pumped out of the heart goes through the artery. So you've got it under really, really high pressure. If it couldn't flex, if it couldn't expand, if it couldn't change its diameter, then there might be a bit of a problem around how the blood then gets out, about where it goes, where it needs to be. So it carries blood away from the heart. The best way I think about it is away. Arteries carry blood away from the heart. Veins visit, so veins bring blood back to the heart. Now there's two examples there that you can see on the screen that are different. So the pulmonary artery, the pulmonary vein go in the different direction, because pulmonary means lung, it's going towards the lung, it's going away from the lung. We've got the arteries that are carrying blood under really, really high pressure. So that means that it's getting shot out at really, really high force and really high speed. Veins don't have that. So veins don't have the same pressure, the same force, so therefore there's a chance that the blood can go back the direction it came. So basically veins then have what we call a valve, and valves prevent backflow, so it stops the blood going back where it came from. So that's one real big difference between an artery and a vein. They have much thinner walls. They have a larger lumen, so basically the central gap, essentially, the diameter, the internal diameter is much larger. They carry blood under much lower pressure, and generally they carry deoxygenated blood, whereas arteries generally carry oxygenated blood. So there's lots of differences in there. And then if we go to the capillary's got very, very thin walls, so they're one cell thick. It's got a really small lumen. It links arteries to smaller veins, and it allows gaseous exchange. So gas will pass through the alveoli, will pass through the capillary, so then we can actually get air from the world, from the atmosphere, into our blood to then be used by the body. So lots and lots of information, lots of me talking. Anybody got any questions on that topic? So looking at the chat, there's a few people that are asking some questions in there. So Dan, is there a way to access the PowerPoint to print for revision? So I didn't make these slides, I bought them as well. There is a website called TES where you would be able to find them from. It would be pretty unfair for me to share it as I didn't make them. So yeah, they are available. You could just do a simple of potentially just watch this video, because they're all going to be on there. There is a video on the channel as well that is all of paper on it, I think in 79 minutes, something like that. So there's lots and lots of things in there. Right, so vasodilation and vasoconstriction is an area that my students seem to find really difficult. Okay, so quite often in the exam they miss marks when they definitely shouldn't. So what happens here is that blood is redistributed around the body. So if you're working muscles, they need more blood, they need more oxygen, we can direct blood or promote blood flow to that area. If we've got an area that doesn't necessarily need as much blood, we can restrict it. And that's what we call vasodilation and vasoconstriction. So your arteries can actually open up, increase their diameter, or they can actually become smaller or dilate and decrease their diameter. And basically what happens there, guys, is that the blood vessel means that it can promote more blood flow, it can increase the amount of blood flow towards a certain area. So that might be digestion, where you've got to send more blood to the digestive system so you can exercise, or it might be your working muscle. So that's kind of how it works. It does help with, it also works when we're looking at temperature regulation, or what we call thermoregulation. So there's lots and lots of things in there. My hay fever is starting to play up a little bit, so sorry if I'm a bit sniffly. Right, so back into the chat along the way. So Sophie was asking about components of fitness and principles of training. Let's go for that topic now. So thanks for hanging around, Sophie. So let's go into, here we are. There you go, principles of training and the components of fitness, okay? So let's start with principles of training. So the principles of training are basically like the rules that you are going to use to train. So if I don't follow these rules, I'm not going to have the same amount of benefit, really. It's not going to get the most from my training. So we have these rules that we call principles, okay? So if I train in this way, I will get fitter. And we talk about them as being the sport principles and the fit principles, okay? So sport principles are basically specificity, which means you're going to make the training matter to you as an individual, and that could be in the situation where you are training in a position. So therefore, as a goalkeeper, I'm going to train very differently to as a midfielder. As a goal attack, I might need different skills than maybe as a goal keeper. There's different things that I might need. So I'm going to train specifically for the needs of my environment, with the needs of my position, the needs of my sport. We've then got progressive overload. So basically, we're looking at how we can try and make the training harder to actually make a difference. So we want to gradually increase the intensity. If I just go straight up, the problem is that I might risk injury. So progressive overload. If I go to the gym after this session, I'm not going to suddenly lift 50 kilograms more than I lifted yesterday. I'll maybe lift a kilogram more or 2 kilograms more, because that would be progressive. We've then got the 4 ways that can happen, and that's what we call the fit principles. So you'll see it on the slide. We've got frequency, intensity, time, and type. So basically, I could train more days in the week. I could train more often, which is what we call frequency. I could train harder, so I could just put more effort in, put more weight in. I could run faster. I could change the intensity, so how hard I work. I could change the time, so I could change how long I train for. That's going to make it harder. I could change for 50 minutes. I could change tomorrow for 55 minutes. I could change the type, so I could actually train differently to make a different impact. So frequency, intensity, time, and type are the 4 ways that I can use progressive overload. We then have reversibility. So reversibility is basically saying, if I stop training because I got bored, or stopped training because I was injured, I'm gonna get less fit. So basically, it might take me 6 weeks to get fit. It'll only take me 2 weeks to lose that fitness. So therefore, there's going to be a reversibility. Instead of going forwards, my training actually goes backwards. And then there's tedium. Basically, tedium, you can just be a bit fed up. So you could just be bored with it. It's not really motivating for you. It's not particularly exciting, which would then mean that maybe your training is not going to be as effective. Okay. So when we talk about the principles of training, that's what we mean. When we hear components of fitness, that's basically saying to us, of all of those different ways that I could train, oh, that's not the one I want. Which one am I going to do? Which is the one that I'm going to work on? So when we look at components of fitness, we've got cardiovascular fitness, muscular endurance, flexibility, reaction time, power, speed, agility, balance, coordination, and strength. Now, in your exam, you need to know the definitions of them, as you can see on the board. You need to know about how they actually matter and how they fit into an activity. So that's the sort of things that we need to do, and the things that we need to understand. Now, in the last 2 sessions, we've gone through lots of exam questions. Today's more of a bit of a request session. So if you want to see any questions, go and watch the last 2 from the last 2 weeks, because that's what we've been working on. So back into the chat then, see if there's anything from anybody that we need to work on. So Sophie saying again, she said she did it in biology recently, which helped her to learn vasodilation and vasoconstriction. Yeah, there are lots and lots of topics which overlap that are in the GCSE exam for PE, and also maybe in your science and your biology exams. So anybody in the chat then, guys, is there any topic that you would like us to go through in the last kind of half an hour that we've got in the session? So we looked a little bit today at the cardiorespiratory system, we've looked at gaseous exchange, we looked at components of fitness there very briefly, and we've had a look at the principles of training. So where we are in these sessions, guys, I keep saying it again, we are trying to get through as many different things as you can to try and see for you guys what you want to do and what you guys understand. Every Sunday we're doing it before the exam, and now we're going to be going through the night before the exam. So ads, now doing A-levels, but this is a throwback. Well, there's probably a few things in the A-level that might be suitable for you, but yeah, it's definitely a lot harder, isn't it? And ads is saying, thank you for getting an 8 in GCSE PE, no worries. Nice to still have you people returning. So again, what you need to do is tell all the GCSE students about where we are, because we're still not necessarily getting the amount of views that we normally get. So there's lots and lots of really, really good things out there at the moment people are doing, and I can completely understand why. Also, maybe the timings aren't right. Maybe we need to do them a little bit later. So before the exam, there's always the night before. That's the one that seems to get big views along the way. So let's just keep going then, because there's not too many requests from people. So what we absolutely need to have a look at is this. So I'm just going to shift my big face out of the way. So there you go, just move me a bit. So here we are. So we need to understand basically about why people do fitness testing and what the issues around it are. So when I examine papers, it's really interesting to see that people believe that fitness testing will actually improve their fitness. It won't. It's like saying that, oh, let's give you a test so that you can learn something. Well, the test is to understand what you've already learned. So fitness testing is going to be used to identify the strengths and weaknesses before you take part in a training program. So I could go and do all these different fitness tests, and I might understand that my flexibility is poor and maybe my muscular strength is poor. So therefore they might be the things that I need to work on, because they might be having an impact in the sport that I play. It helps you to identify the level that you are currently at, because what happens is that there are a set of data that can show us where we're at, how fit we are in comparison with a group of people. So where we are using this data is to try and say, are you excellent, are you good, are you average, are you below average, are you poor? What that means then is that I can identify where I'm at, and therefore it might give me an indication of what I could be like at a particular sport or event that may need those different fitness components. So when you're going through fitness testing, you need to understand why we do them. You also need to understand the limitations. So basically, why might they not be the best things to do? So what's important there is that you guys all understand about the fact that testing might not actually make you best at your sport. It might not mean that you actually gives you the information you want to know, because quite often these sports need a particular type of test that actually doesn't exist. So quite a lot of the tests are really, really general and not sport specific. So if we take this one here, the sit and reach test. So the sit and reach test basically tests the flexibility of your hip joint and around your hamstrings. Now, if I'm going to be, let's say, a swimmer, I might need more shoulder flexibility. So it doesn't really necessarily indicate what I'm going to be like in my activity. So they're not generally sport specific, or they're too general. That would be a mark that you could put in the exam. The movements required don't necessarily test the thing that you're going to be doing in the activity. They also quite often are tests that require a lot of effort. So if you take, let's say, the multi-stage fitness test that you guys might know better as the bleep test, the easiest thing to that is to pull out because you got a bit tired. It's not necessarily showing your full cardiovascular fitness because you just stopped. You got a bit tedious. You got a bit bored with it. So that's the sort of thing that we need to be putting in the exams if you get anything about the limitations of fitness testing. Some of the tests are actually not necessarily reliable because you might be doing a stopwatch. You might have placed cones out. Did you measure it out correctly? Did you follow the full protocol? So are they reliable is always an issue. So you've got those aspects about the reliability, about is it testing what it needs to test? Is it specific to my activity? And is it actually a full measurement, or is it guessing what my fitness level might be based on just the general score? So there's some of the things that you would need to talk about. So Sophie, what sort of questions would they ask about fitness testing? So you would be asked questions like the fitness test for agility is the Illinois agility test. Describe or explain the protocol for the Illinois agility test. So in that question, you would need to talk about how far apart the cones are, how is it measured, how does the performer begin, do they change their body position when they do it. So the fact that we start on our tummies, we then run 10 meters, we go in and out the cones, we go back up again, we change direction. Those sort of things are what they're going to be asking about the simple protocol. You'd need to know about each test and what it tests. So that's what you can see on the screen at the moment. So the fact that the sit and reach test tests flexibility. You'd need to know the reasons for fitness testing and the limitations of using fitness testing, maybe to predict performance, things like that. So there's a few different areas that you could get in the exam. So they'd be the sort of questions that you'd be asked. Now, I would think that we're going to get something relatively significant on it. It could be a 3 marker. Just understanding those sort of things. You might be given a set of data. So it's understanding how the data was going to give you information. So there is different data for different genders. So it's understanding where it says male, where it says female, about what a good score is, what a poor score is. And then you use the information to go, that's what it is, that's what it means. So just things like that, really. They're the sort of things, Sophie, that you would need to understand. Now, I think in the AQA exam that we will get a question around this. I reckon there's going to be something around warm-ups and cool-downs, which obviously we've got that completing a warm-up in there. So we want to understand this about how we warm up and how we cool down. We would like you to understand about the benefits, the reasons why we do them. Now, I don't know why, it's just a sneaky suspicion. I think a 6 marker on paper 1 is going to be about warm-ups and cool-downs, or something around that. So if you're going to go and do a warm-up, the worst thing that I see every time is that people do stretching first. Now, if we take, let's say, a pack of chewing gum, if I go and grab that chewing gum and start trying to stretch it, it's not going to go very well. It will probably break or it will probably snap. Now, if you then chew it and then try and stretch it, it's way more flexible, it's way more pliable. Your muscles are the same. So the first stage of a warm-up has to be some sort of pulse raiser or trying to get oxygen around the body into your working muscles. So that's probably going to be something like the example on the board of jogging a lap of the pitch or going for a run or skipping or whatever it needs to be. The reason that needs to happen is it's actually going to increase the temperature. Remember, a short-term effect of exercise is raising temperature, so that blood's flying around the body, the temperature of your muscles will increase. What that then means is that when you then go to stretch them, you can then stretch them across their full range of movement. So if the first time that you try to get your hamstrings, for instance, going over a large range of movement, the problem is that if you do that when you're sprinting, you might get quite injured. So we need to ensure that when we are exercising, that stretching comes after our pulse raiser. That's all about preparing our body. It's trying to prevent injury. It's trying to make sure that we are physically prepared for our activity. We also need to be mentally prepared. Now, what that's going to mean is that you've got to do some sort of drill or sport-specific exercise. So let's say I was playing cricket. The first time that I caught the ball, hopefully, is not going to be in the game. If I'm playing netball, the first time that I take a shot should not be in the game. So we've got to make sure that we're actually preparing our mind for what we're about to do, so therefore we're ready for it. So one of the benefits, first of all, is that to be physically and mentally prepared for the exercise or the physical activity. So that's something that you absolutely need to try and understand. We then look at the other aspects that you can see on there as well. So we're going to look at the fact that it's going to increase oxygen delivery to the working muscles. Well, what that means is that you're going to reduce the oxygen deficit, so therefore along the way the oxygen debt will be smaller. We can look at that in a second. We're going to increase the temperature of the muscles, the ligaments and the tendons, so the connective tissues as well, which reduces the chance of injury. And we're going to increase the range of movement around the joint, which should aid performance. So I could kick the ball further, I could throw the ball further, I could run faster, I could jump higher, all those sort of things. So I've gone and done my exercise, I've gone and played my game, I've played my sport, and then at the end I should do a cool down. So a cool down comes in two parts. The first part is that we need to do some light exercise. So you've got to do some slow jogging at a much lower intensity than what you've been working at. So it might just be a slow shuffle around the pitch, a slow jog, something which is a reduced intensity from what you were just doing. We then stretch, and we're going to stretch the major muscles that you've used in the activity. So we stretch in the warm-up, we stretch in the cool down. Now, the reason we do a cool down is we want to remove the waste products from exercise. So we want to remove lactic acid, we want to remove carbon dioxide. What that will also help to do is prevent what we call DOMS, or muscle soreness. So DOMS is something that is going to come way after you exercising. Generally it's 24 to 48 hours after. And what it stands for is delayed onset of muscle soreness. So let's say I was to go to the gym today, I might be absolutely fine tomorrow, but on Tuesday I might feel like my legs are going to fall off. So doing a cool down can actually reduce those sort of symptoms. We also want to try and get our heart rate and our breathing rate back to normal, or back to rest, nice and slowly. Okay, so we're not going to shock the body, we're not going to just suddenly stop, we're gradually slowing down. So that's why we're looking at that intensity just being a bit lower. And that's going to help to reduce things like dizziness, about how you feel. You might feel faint, about blood pooling. So basically, if you just stop, that blood's whooshing around the body, it's got nowhere to go. It might just sit around and pool. It's also then going to maybe improve flexibility, because you've got these more muscles, we're stretching again, it's going to be able to go over a wider range of movement. So therefore, it's not designed to prevent injury, it's purely about trying to bring everything back to where it was at rest. So I would argue that a cool down is more about improving performance on another day than it is about preventing injury. So let's just pop over to the chat again, see if anybody's got anything to say. No, everyone's a bit quiet today, not a big issue. So this is where we are, guys. So we've got all these different topics, all these different areas, and a few key bits that you would all need to know. Now let's have a look at this one, because this is something that I don't think we necessarily focus on as much as possible. So in paper 1 and in paper 2, you can get a question around data. So the data is basically going to be looking at either qualitative data or quantitative data. So qualitative data, it has a quality, okay, whereas a quantitative data has a quantity. So the quality is basically things like observations, interviews, people observing somebody playing, and it's opinion rather than being fact. So let's say I was to watch Leicester this afternoon, we won 5-1 against Watford, amazing. James Maddison, absolutely perfect. That's not my opinion. That is a qualitative data that I've collected. If I was to count how many passes that they did, how far they ran, how many goals they scored, how many assists Maddison had today, how well Harvey Barnes played, as far as how much distance he covered when he ran, that's all a quantity. It's actually a number that you can't argue with, because it is just a fact. So we've got qualitative data and quantitative data. Now, we see these questions quite regularly, and students sometimes come away going, I don't know what it meant. You might get a small question saying, what is qualitative data? What is quantitative data? You might be asked about looking at a graph and showing what it, and asking what it shows. So if we look at these ones over here, for instance, obesity and diabetes is both risen from 1990 to 2008. So basically that graph has generally gone up. Obesity levels have generally gone up. But you'd argue that one of them has gone up more than the other one. And that might be the sort of thing that you would talk about. You might see a bar graph. You might be asked to present what you see from the bar graph. You may get information about fitness testing to see what's the result, good, excellent, not so good. It's just asking you to look at it and understand it and interpret it, which is still the sort of things that you'll do in a job. You might be presented with a load of data and you've got to try and say, well, this is what it means. We need to sell to these people. We need to put our YouTube videos on at a certain time because that's when more people watch. So all about analysing data. So let's have a look. So Paddy is asking for planes and axes. So planes and axes is not going to be a big focus in the exam, but we will go through it for you in a second. Synovial joints, we'll go back over that in a second. And we've then got Jamie who's asking for any tips answering the 9 markers. We can do all of those. So let's go back over this one and we'll go to the planes and axes part. Okay, so first things first, okay, can anybody tell me what a plane is? What does it mean? What does a plane of motion mean, or a plane of movement actually mean? Does anybody know that part? Because if you don't get that, you're kind of in a situation where planes and axes are always going to be difficult for you because you don't actually understand what it's asking from you. You don't necessarily understand what the question wants you to do. So when we look at planes and axes, you need to understand exactly what a plane is and what an axis is. So a plane is basically a direction of movement. So what we're saying here is that we can either move forwards and backwards, we can move side to side, or we can rotate. So they're the directions of movement that basically everything that we do actually is. So if I'm looking at going forwards or backwards, I'm basically saying that I'm going to go either in flexion or extension. That's moving forwards and backwards. Simple as that. So where we look at that sagittal plane, that is either moving forwards or back, because the body's been divided in half and we either move forwards or move back. It's as easy as that. Where we look at the fact we might move from side to side is that because we have created a frontal plane where it's gone from a front and a back, well, the only 2 movements that I can move are to the side. I'm going to move like that. So that is where we're looking at adduction or abduction. That only happens on a frontal plane. We've then got a transverse plane, so a top and a bottom, like that. The only way we're going to move there is some sort of rotation. So basically, I'm either going to do flexion extension, I'm going to do abduction or adduction, or I'm going to rotate. And that's either on a frontal plane, a sagittal plane, or a transverse plane. Now, when we then look at axes, axes are about how you're maybe going to then rotate in that position, because we rotate around an axis. If I'm on a chair, I'm rotating around an axis at the moment. So they always come in a pair. So every time that I am going to be doing flexion or extension, or moving forwards or moving backwards, that's always going to come with a transverse axis, because I'm either going to basically bend from the waist, okay, and it's going to be enabling that movement to happen. So if I did a somersault, I'm going to move my body into flexion. I'm then going to be rotating over the top, so my head going over my heels. Now, it doesn't have to be a full rotation. When you're running and you lean forwards, that's a transverse axis. When we look at a frontal plane, so frontal plane, this idea of moving sideways like that, I'm going to have to get kebabbed essentially through the middle of me so I can rotate that way. So the best way I have for this one is that if I do a cartwheel, I fall sideways. So a frontal plane and a sagittal axis, the F with the S. So falling sideways for a cartwheel. A goalkeeper saving a shot, same idea. It doesn't have to be a full rotation, it just has to be some sort of movement in that direction. We've then got a transverse plane and a longitudinal axis. So basically, if I'm going to spin like this, or if I get my phone, bit of merch, woo, like that, that would be an example of the longitudinal axis. Me sitting on my chair, spinning around this way is the longitudinal axis, and that always comes with a transverse plane. So they always come in pairs. So learn your pairs, and that will be amazing. So hopefully, the person who's asking about planes and axes, that should help you out a little bit. Let's just see in the chat if anyone's got something to say. So someone said, is it like how much you move? So remember, a plane is just merely a direction of movement. It's not about a degree, purely about how you move. Right, so we've then got, so someone's asking in there about synovial joints. Synovial joints, let's just go over that. That was one of the first pages that we had. Okay, synovial joints. Pretty easy if you get it, but we'll do that now. So a synovial joint, basically a synovial joint are the joints that are going to be moved in the bodies. They are the ball and socket joints, they are the hinge joints. They are all made up in the same way. So first things first, they are synovial joint, they have synovial fluid. synovial fluid is lubricating the joint and reducing the friction. So it basically means that we've got this smooth movement between the bones, where we're going to be not having any sort of friction or any sort of collision, essentially. So it's more about the friction, so they're not going to keep rubbing past each other. Synovial fluid is created by the synovial membrane. Okay, so that's literally what the synovial membrane does. It contains and it releases synovial fluid. So therefore, without synovial membrane, we couldn't have synovial fluid. Without synovial fluid, we'd have loads of friction. We then got the cartilage. So the cartilage is stopping bones from hitting each other. Okay, not ideal. Remember, over time, I think every time you run, your bones are moving closer together. Over time, those bones would obviously disintegrate. Not the best for us. So the cartilage is basically acting as a shock absorber. It's just stopping the bones from colliding. We've then got the joint capsule, which is like a big bag essentially. It surrounds the synovial joint and basically stabilizes everything. It kind of keeps everything in place. We've then got the ligaments, which is helping the bone to bone connect, because otherwise they just sit around and wouldn't move, we wouldn't have a joint. So therefore that's actually giving us some stability to the joint. It's the thing that's kind of holding everything in place, as far as the bones, I should say. So if you ever see in football somebody, they think they may have torn their ACL, they'd actually seen, is there any movement? Because if there is, those bones probably aren't connected anymore, so therefore maybe that ligament isn't connected to the bones. And then we've got the bursa, and the bursa again provides a bit of a cushion, but actually it's all about reducing friction. So bursa is a little tiny sacs of synovial fluid that just sit around in the joint. So if you're not sure, put reduces friction, because for most of the things in the synovial joint, that's what they do. They reduce friction. Okay, they provide free movement. They're kind of your go-tos. If you're not sure, they'd be the things to say, because that's what happens. Right, so pop back into the chat. Let's see what we're saying. So back into the chat then. Do the planes and axes go in pairs then? Because I always thought they were in separate. No, so yeah, there wasn't a pair, so I couldn't. Going to use my phone. I couldn't run forwards whilst doing that, because that would be really, really difficult. So imagine like running forwards but rotating like that would be really hard. So it has to be with a particular pair, otherwise you'd be sort of defeating the laws of gravity. Anyone else in there in the chat? So there's a bit of delay, so that's why sometimes the flow goes, because I think I'm about 20 seconds in front of everybody on YouTube, and obviously then with the chat, blah blah blah. Okay, so there's something else that people want to go through. Synovial joints, right? Tips for 9 markers. Yeah, absolutely. Right, let me just get something up then, because I've got some stuff on that one. So 9 markers are funny questions that people struggle with, and they really shouldn't, because you all know the answers, but for some reason don't always want to give your best answer, basically. So I'm going to get a extended question up. So let's just go from here. I'm just going to get a 9-mark question up from the website I use to get the questions, and we'll try it together as best as we can. So let's go for, let's see. Here you go, extended questions. Ooh. Let's try this one actually, yeah. Let's do that one. So I am just going to grab this one here. Sorry about this, guys. I'm just doing this on the fly, which is something I don't normally do. It's all very planned normally. Right. Okay, so I'm just going to crop this. You might be seeing me doing it as I go. Just make your life easier. So here we go. So extended question. This is going to start with a 6 marker, and then we're going to develop these into 9-mark questions. Okay, that's kind of how we're going to go. So here is a question that you guys are going to hopefully give a go. We're going to do it together to see what we need to do. There we go. Just checking that it's actually with you guys. It's quite difficult here trying to be a YouTuber when you're just a general PE teacher. Okay, so evaluate the importance of plyometric training and interval training to a games player. So the first thing that you guys all need to understand is, how do we get the marks? Okay, how do we get the marks in these questions. So does anybody know how many marks I can get for purely giving facts? Does anybody know how many marks I can get in addition to that if I give some application? And does anybody know how many marks I get for evaluation? So basically, how many marks do I get for AO1, how many marks do I get for AO2, and how many marks do I get for AO3? Okay, that's the first thing that we want to understand. Again, I know I'm in a bit of delay here, so I'm waiting for the chat. So I'm just going to go back to see what people have been writing. So, how do you remember the order of blood through the heart of the body? Is there an acronym? Ooh, we'll look at that in a sec. There's a couple of things. So, if you know the fact that we go for the atrium before the ventricle, think about Aston Villa, would be the way that I do that one. And then from there, we should know that all the arteries are going away. So if you know what the arteries are, then you should be okay. Mason is saying that level 3 BTEC tomorrow. Thanks for the videos that you've made. No problems. I would love to do more BTEC level 3, so I might be adding that to the channel very, very soon. Could you go through the respiratory system? We did that earlier, Paddy, so you need to have a look at that. So Paddy, go back to the video when I finish because we have done that one already. Right, so here we go, 6-mark question. So in a 6-mark question, I get 1 mark for AO1, I get 2 marks for AO2, and I get 3 marks for AO3. So what that means, guys, is I'm gonna get 1 mark for just giving facts. So in this situation, I would talk about what plyometric training is and what interval training is, okay? That's how I'm gonna get the first set of marks in there. So when I then do it, I'm looking at the fact that plyometric training is involving some sort of hopping, some sort of bounding, some sort of jumping. That's how I'm getting those first marks. The point of it is to develop power, speed, or explosive strength. Whereas interval training is a method that incorporates periods of high intensity exercise followed by periods of rest. So intervals have a break. Plyometric training, I say, it doesn't. Okay, so where we need to understand is basically similarities, differences. Now, what you then need to do is some AO2. So let's take, we've got the netball example that we're going to use. Okay, so our netballer is going to use plyometrics because it involves jumping. Jumping is vital to netball because they want to be able to reach the ball, they want to be able to intercept the ball. That is me being in a situation now where I'm doing an evaluation. Now, quite often, people do that first. What we actually need to do is just simply say, plyometric training could be helpful for netball players because they require power in their legs. That's it, that's an AO2. The AO3 is that you're saying it's gonna mean that you can intercept the ball more. It's you being evaluative to saying, by me having this, it's gonna help my performance in this way. If I take leg power, well, leg power is gonna be used to dodge quickly away from an opponent. Okay, so that's an AO2, I'm just saying how it's used. Well, why is that important? Well, it's important when I'm marked closely. So for instance, in the center pass, I might need to get away quickly to stop a pass being intercepted. So all we've got to do on these extended questions is basically go, here's the facts that I know. Here's me now applying it to the activity, and here's me then evaluating the importance of it. Now, these are generally answered quite badly. I think the national average for the 6-mark question is around 2. Okay, I think it's about 2.5. So we need to just develop the fact that we're not just skipping the AO1s, that actually we're in a situation where we're just giving the facts that we want to do. We're not just jumping past the AO2s because we've got to say exactly how your AO1 fact is going to be used in that activity or the scenario it's given you. And AO3 is you going, here's the importance of it, or here's an alternative. So that's something that all of you can do, but it's about your skills, it's about your structure when you do it. Okay. Now, for a 9-mark question, the only thing that changes is it's 2 for your facts, 2 for your application, and 5 for your evaluation. So really, if you know the skills, if you understand what AO1 is, what AO2 is, what AO3 is, you should be absolutely fine. Okay, so let's just go back to the chat and see what's said. So 1, 2, 3, just a guess because they get harder. Yeah, well, yeah, but it's it's understanding where the AO1 is and where the AO2 is. I see far too many people who miss the AO2 out, so therefore the bit that is showing your knowledge, that's the bit that lots and lots of people are missing out. So rebounding is plyometrics for the netball. Absolutely, that'd be a really good example for it. So rebounding for the netball, and then you could talk about an AO3 about the importance of that. So how does the rebounding actually affect the performance? Well, I'm going to get the ball more often. My team are going to not lose possession because I win the rebounds. It's things like that. So we've only got a couple minutes left. So is there anything else that anybody wants to say in the chat? Anybody wants to go through before we log off? And then we see you again next week, where we'll have a few different ideas, and obviously then the night before the exam. So if you're not already, guys, obviously subscribe to the channel, like the videos, it definitely helps. And also I'm on YouTube, I'm on Twitter, and I am also on Instagram, so planet_PE in those areas. Joe, do you do A-level? Sadly, I don't at the moment. I think I've got one video on there because someone asked about attribution theory, so I put that on there. But at the moment, I don't have any videos on that. The Everlearner is a great channel to have a look at for that one. He's got lots and lots of good things, and he's gone through some live revision sessions and has some work that you can kind of do along with it. So anybody else, guys, anybody really got any topics that you want me to briefly go through, or any comments that anybody wants to make? Will the live session be on Monday or Sunday? So the live before the exam will be the night before. So if the exam's on the Tuesday, we'll do one on the Monday night. So that's kind of how that will go. No problem, Jamie. No problem, George. Thanks, Walker. So let's get ourselves off, and I'm going to sign off and have a great evening, and good luck in everyone's first exam tomorrow, which I think is RS. Good luck, everybody. You'll be amazing. If you put the work in, you will not need to worry about a single thing. Well done, guys. Bye-bye.